Okay, we got a good live stream. In 1 second, folks, here, let me get this screen sharing going and we'll get our program started. We're at the Library Telescope program, so we have a great program for you tonight. So good evening. My name is Don Ficken. I'm with the Library Telescope program, and I've got with me tonight Mike Modrcin and Chuck Sims that'll be helping me. We are going to have a really interesting program. You may have heard there's an eclipse coming up. And Mr. Modrcin is a NASA Eclipse Ambassador. He's part of our Library Telescope task force, and he's going to talk about that. So in just a moment, but before we do that, let me just go over a little bit about the Library Telescope program if you're not familiar with that. The Library Telescope program is a program where a patron can simply check out a telescope from a library, just like a book, and they can also check out binoculars. And there's over 1,000 locations, and it's in 6-something countries. We've got a great world map that if you go to librarytelescope.org, you can search out at least the programs that we know about. There's probably a lot more, but it's a really great resource if you want to get started in astronomy and just to play around with a fairly powerful telescope. We have our goal is simply to grow the program and share best practices. We get together each month to talk about how is people that are working with the libraries themselves to figure out how we can do the job and grow it more. We have a Facebook page. It's well over 6,000 followers. We have a website that's got a lot of really great maps on there and a number of resources, not only for our patrons to use the telescope, but also for our libraries themselves. Also on the website, one of our members has been drawing with the Astronomical League, has been drawing maps of the night sky for each month. There's a map for March that you can see here. He's got usually a few maps, one in English and one in Spanish, and then he'll have a few other maps that bring up some really cool stuff about you might be able to see over the next month or so. And of course, we've been doing this for quite a long time. We're up to our 38th, I think, program, and these are all posted on the front page of our library telescope.org website. And then the night's program, of course, is the April 8th, 2024 eclipse. We will be taking questions at the end. We are live streaming both on YouTube and on Zoom. So if you can hold your questions and just place them into the chat if you're on the Zoom area, or if you're into the YouTube, just put them in the comments area, and we'll be watching for those questions. And with that, I'm going to turn this over to Mr. Mike to get going here. Mike, it's great to see you, and you're looking dapper.
Right, thanks.
Ready to talk about this exciting eclipse coming up. So if you want to go ahead and do your screen share, we'll get going.
Yeah, looking. Yeah. Let's pull this up here. Does that look good?
Yes, it does. Thank you.
Okay. Get rid of this bar. All right, so yeah, we are or I am, I guess I should say, Mike Modrcin. I am an outreach coordinator with the Omaha Astronomical Society. I am a NASA partner Eclipse Ambassador, and I am part of the International Library Telescope Task Force, which helps to promote the Library Telescope program across the country and throughout the world. And so today we'll talk about the upcoming April 8th eclipse. And our eclipses here on Earth are, some of the most amazing shadows cast in the galaxy. And let's get into it. So first off, a little disclaimer. We kind of feel, the members of the task force feel and recommend that we should remove the Library Telescope Task Force from circulation at least a day, if not the week before the actual eclipse, just to prevent anybody from using a library telescope to look at the sun, which without the proper knowledge and equipment, it can be tragically detrimental to their vision. And so it's not something that we recommend. The library telescope should never be used to look at the sun, and you should never look at the sun without a ISO rated solar viewing glasses or some other rated certified solar viewing filter. So what is an eclipse? Well, basically an eclipse is just any time that a celestial body blocks the light of another celestial body. So the Earth blocks the light of the sun from the moon, or the moon blocks the Earth or blocks the light of the sun from the Earth. So we have solar eclipses, lunar eclipses. There's also the total eclipse of the cat, which happens when one is a little bit more camera friendly than the other. And so to have an eclipse, you have to have those three ingredients. You have to have a star, a satellite or moon, and a planet. So we have, I think that's Sirius, and I can't remember which moon that is. And then that's the planet Mercury. But that's not the ones that we're talking about today. We're talking about our sun, the star of the show here. And it's a big ball of burning hydrogen and helium. And one thing that's notable about this eclipse in April versus maybe the 2017 eclipse that many people across America were able to see is that now we are in solar maximum, whereas then we were just coming off or just going into solar minimum. So the sun has an 11-year cycle of minimum, maximum, and back again, where there's like on the image on the left, there's a little bit of solar activity and it's kind of dormant. And then all of a sudden, the twisting of the equator spinning faster than the poles causes this churning of the fusion on the sun, which creates all this extra activity, sunspots, prominences, filaments, things kind of go haywire. And so we're into that period now. And so it gives us the chance to see a lot more with the corona and the chromosphere once you're in totality. You have to have a satellite, or in this case, our moon, the only one we have. But one thing that's really unique about our eclipses and our moon and sun system that we have is that the relationship of the sizes is just so perfect. A lot of planets have moons, and all planets really orbit stars, but it's very, very unique to find a planet with a moon and a sun that are in this perfect ratio of the moon. The sun is 400 times larger diameter than the moon, but it's also 400 times larger farther away. And so the apparent size in the sky is almost identical. And so that allows us the moon to perfectly block our sun, in the sky, and allow us to see different parts of the sun's, kind of layers than what we can normally see without that. And then, of course, we have to have a planet, which is our planet Earth, which you can see just in the very center of that image, that little white dot. This is a famous image that Carl Sagan famously quoted as, a mote of dust caught in a sunbeam. Space is big, light is slow. We are all very small, kind of thing. And so the Earth, the sun, and the moon, we're always spinning. The moon is always spinning around the Earth, and the Earth is always spinning around, revolving around the sun. So why isn't this a regular occurrence? But some people might think that the Earth and everything, you see it on a map or in an image, it looks very flat, like everything is rotating around on the same plane, and that's just not the case. So we're going to watch a very short video here to kind of give you a graphical representation of how the tilt, the wobble in the lunar orbit affects our ability to see eclipses. And so there it looks like everything's just happening on the same plane, but when we get down to it, sometimes the moon is too high. Sometimes the moon's orbit's a little low. And so only when everything is right in line, typically during equinox, the spring and the fall equinox, that's when we are able to have those eclipse moments. And so there's typically 2 a year, but the Earth is very big and it's covered with mostly water. So a lot of the time, these eclipses are happening out in the middle of the ocean, and nobody really gets to see them unless you happen to book a ticket on a eclipse cruise or something out to the middle of the ocean. And they happen all over the planet in different countries, different continents. Just kind of depends on where things line up. And not all eclipses are the same. So we have, oops, sorry. We have different types of eclipses. So in last October, you might have heard people talking about the annular eclipse, which is the ring of fire you see on the left side. And that's a little bit different. During an annular eclipse, it's never safe to take off your eclipse glasses because you're always seeing part of the photosphere, but you get that really impressive annulus, the ring of the edge of the sun. And then there's the total eclipses, where the sun is completely blocked. The photosphere of the sun is completely blocked by the moon, and so we're able to see that corona, and you can see like a prominence coming off on the very top there, and some interesting features that happen. And so the reason for that is not only is the moon's orbit not flat, it's got that tilt to it, but it's also not a perfect circle. It's an elliptical orbit, so sometimes when it's orbiting, it's a little bit closer, and sometimes when it's orbiting, it's a little bit farther away. And when it's a little bit farther away, it appears smaller in the sky, and that's when we get the annular eclipse. And this April, when it's going to happen, it's going to be a little bit closer to the Earth. And so you can see on the right side the difference in that apparent, the apparent size you see in the sky. And that's a function of that elliptical orbit. And that's what allows it to block more of the sun than we had in October, because it's just going to be a little bit bigger in the sky and cover just a little bit more of the sun for us. So where do you need to be to see this one in April? Well, you can start down in Mexico. You can go through South Central Texas, up through Arkansas, into Indiana, and all the way up through Maine there. And anywhere on that path is where you'll be able to see the actual totality event. If you're just over here, just off to the side in in Oklahoma or in Missouri, and you're just not quite on the path, a 99% eclipse is nothing like a total eclipse. And the closer you can get to the center of that line, that path of totality, the center line, the longer you're going to have to experience that totality moment. So in 2017, we only had like 2.5 minutes maximum of totality, depending on where you were at. On this eclipse, we're going to have almost 4.5 minutes. You're going to get to experience it for that much longer if you're right on the center line of that path. And so even if you're not on the center, you're still going to get experience totality. Here in Omaha, you're going to have about 80% totality. Other place, the farther you get away, the less and less percentage of coverage you're going to have. Thank you. But certainly if you have the opportunity to travel, would recommend that. And so throughout history, people have lived for thousands of years, and we've always had these eclipses happening. And depending on where your culture came up from and what your mythologies were, you had different stories that you told about the eclipses. And a very prominent theme with these was that there was some mythological creature that was attacking the sun or taking a big bite out of the sun. And so lots of things like to eat the sun. And in Vietnam, historically in Vietnam, there was a giant frog that was taking a chomp out of the sun. Maybe there was a mischievous black squirrel that was trying to take it like a nut and stash it away. Um, as you can see in the background of this image, in Norse mythology, there was a giant wolf, Fenrir, that was gonna gobble that sun up. And for all those same reasons that people thought the suns disappeared, we also tried to come up with ways that we could make the sun come back. And so different cultures used to do different things or have different stories about how the sun got released, whether there was a noble mouse that chewed through the snare that was binding the sun, or Native people in South America lighting bonfires along the hills to help reignite the flame of the sun, beating loud drums to stir the sun back up. We've always, had eclipses affect us and be a part of our cultures. Also, historically, there have been dramatic side effects of eclipses. In England, there was an eclipse that coincided with the death of one of the monarchs, and it led to kind of a bloody, revolution or civil war to fighting over the throne. But more happily, way back in 585 BCE, we had the Lydians and the Medes were in a deadlocked kind of stalemate, bloody war that had been going on for years and years. And, at the height of one of their battles, the sun disappeared from the sky and an eclipse happened. And as a result of that, they thought that that was a sign from their gods, and they threw down their weapons and established a peace treaty shortly right after that. And so, then that eclipse probably saved a lot of lives. So how do we view these things? Because that's really, you can talk about them all you want, but until you get to see one, that's kind of where we're at. And the easiest and simplest way is with eclipse glasses, which you just, they're a special type of material, usually in a little cardboard kind of paper frame, and you put them on and allows you to look at the sun. You can use them to look at the sun at any time. It doesn't have to be just during the eclipse. But you want to make sure that your eclipse glasses are ISO certified, and we'll talk about that in just a second. You can also, the other best way, especially one that's great for libraries, is to have your patrons come in and make pinhole viewers, which allows you're actually looking away from the sun when you use those. So there's zero chance that you're going to be able to damage your vision. So when you have your eclipse glasses, you can, one great thing to do with, especially if you have kids, you can have, the library can have paper plates, and kids can come and take their eclipse glasses. You cut out little holes for the eyepieces, like this guy in the bottom right, and then they can decorate the plate, and it provides a bigger mask so that even if that shifts on their face a little bit, especially with smaller children, they're going to have coverage, so they're not getting any of that stray sunlight coming through around the edge of their glasses. Plus, it's just fun, for them to be able to jazz those up. So here's the certification that you want is ISO 12312-2. And anything that doesn't have that printed, and there's usually a little globe logo that goes with that for the ISO symbol. You really want to make sure that you're using legitimate certified eclipse glasses, just to maintain absolute safety for that viewing experience. You definitely do not want to use your glasses and then use binoculars in front of them or a telescope in front of them. That will not protect your eyes. It can be very dangerous. You're magnifying all of that light and heat into a fine little point with those optical devices. And as you can see in the image here, we have someone who was using a pair of binoculars, and in this case, as it was reported on the internet, was lucky enough to pull them away when they realized that something was going wrong. And they didn't have permanent vision loss, but it's very dangerous. So you must use these things responsibly. And if you're with children and stuff, make sure that they are also, not misusing them, because they're really only designed just to look straight at the sun with your Mark 1 eyeball. So we were talking about the pinhole viewers. And so one thing that I think is great for libraries to do is to have a BYOB party, a bring your own box. So you can have your patrons bring a cereal box, a shoe box. Everybody's got an Amazon box laying around these days, it seems. And you can take it and you can make a pinhole viewer out of that box by tracing the bottom of it to make onto just some white copy paper to make a projection screen, which goes into the bottom of the box. You can use tape, or you can use a little glue sticks, work really well just to get that to stick down there. You cut off a couple of little squares in the opposite side of that. One becomes your pinhole and the other becomes your viewing port. You wrap some foil around there and tape that down and then poke a little hole. And a pinhole is really not what you want. You actually want something more like 1/8 of an inch or so to be able to give you a good projection. But then you will actually get to see like a camera obscura, like the very first type of camera, the eclipse going through there, and you're looking away with your back to the sun and it coming in to the other side of that. You can also make it out of, as you see in the bottom right corner, you can use a big cardboard tube, like a 2-inch cardboard tube that they use to mail like posters or larger prints or something in. And you cut a hole there and you put the foil over the other end, and then do the same thing. You're projecting this at the sun, and then you'll see the image down in here. You can also use something as simple as your colander, your pasta strainer, and you'll create tons, dozens of little mini eclipses using that pinhole projection concept. This is a lot of people have these Lotus style steamer baskets. Just making small holes with your fingers can create little pinholes to project the eclipse. And you don't even have to do anything. You go out someplace where there's trees, and you will see the space between the leaves will actually create the same type of effect, and you'll see these weird shadows during the eclipse that are kind of cool and worth maybe taking a photo of. And then, of course, if you do have a telescope or binoculars, and you have the proper solar filter for that device, or a dedicated hydrogen alpha fancy solar telescope, I mean, absolutely you can use those things, but only if you have, equipment that's specifically designed for this purpose. It's very, very dangerous to try and jerry-rig something that's not designed specifically for solar observing. And then if you don't have the option of getting to totality, certainly you can hop on the internet and you can watch a live stream from a lot of different sources. They'll be all over YouTube and Facebook and Twitter, and everybody else will have these live streams going on. Two I recommend are the Exploratorium, which is out of San Francisco, and then of course our good friends at NASA will have an excellent live stream opportunity for you there, where you can see totality happen, on your TV screen. So several things that you can look for if you happen to be on the path of totality are going to be during different phases of totality. You can notice different things. So you might have noticed my awesome shirt that I'm wearing. And this is a Purkinje effect shirt. So what happens with the Purkinje effect is the changing light as the eclipse happens will shift how our rods and cones in our eyes sense color. And so the red part will become very gray and the saturation will go way down, while at the same time the green will stay bright and vibrant. and maybe even increase a little bit in saturation. And it's just a unique phenomenon. So anybody who has the chance to stand around me will get a stare at my back and say, "What the heck's going on with that guy's shirt?" I hope, at least. You can also see something called Bailey's beads right before totality, or right after it. The moon is not a perfect smooth ball. It's covered in mountains and rocky formations. And so as the very last bit of the sun goes behind the moon, sometimes there's going to be little mountains and there's little valleys, and it will create what we call Bailey's beads. And it's kind of a very pretty thing that you can notice right at the point of right before the point of totality. And then, of course, nothing I can say can really explain what it's like to see totality when you can get to that point and you can take your glasses off and you can see the chromosphere and the corona of the sun with the photosphere fully blocked by the moon. It's I had the chance to see it in 2017, and it's definitely worth traveling for if you have the opportunity and the ability. There are shadow bands. So when the sun is a very slight crescent behind the moon, it creates a very focused kind of shape of light, and just the rippling of our atmosphere will cause that little cast of light to kind of manipulate around. And so we get these unique shadow bands. So something a library could do is have a big piece of white poster board. If you're on the path of totality, you could have that laid down and allow people to see that shadow band kind of look kind of like a bunch of snakes moving around on the board. And then also the diamond ring, which is kind of similar to the Bailey's beads, but in a much larger scale. You have just this sliver of light around, and then the bright diamond of the ring, either right before or right after totality. So if you want to get involved with science, to go with the eclipse, there's something called the Globe Observer, and they have an eclipse program. There's an app you can get. They're interested in recording sounds of the nature and the birds and the crickets and things, and how that changes during the totality, or even just different parts of the eclipse, because that will affect wildlife and the nature around you. There's also for temperature, if you have a digital thermometer, you can monitor how the temperature dips during as the sun gets more and more blocked, and then comes back up as it's revealed again. So there's information there that we can make sure we include in the description of the YouTube video. And with that, I will reinforce the fact that you should never, ever use a library telescope to look at the sun. And you should always make sure that you have, certified protection. If you're using a telescope, binoculars, your eyes, always make sure that whatever you're using is, designed specifically for that purpose. So if there's any questions from anyone, I'm happy to try and answer them.
Okay, that's great. So why don't you go ahead and stop screen share, unless you have something up here you want them to see, so we can chat a few minutes here. Yeah, by the way, thanks for that's great. That's really great and very helpful. Let's see, do we have any questions yet? I don't see any questions quite yet. So let me just ask. I want to reinforce. So I get a lot of questions here. I live in the Metro St. Louis area, and if we travel about an hour and a half south from St. Louis by highway, we could be in the path of totality. And they say, well, we're 99% here, 98, 99%. That sounds pretty darn good to me. So can you explain the difference between 99 and being in totality? Is that the same thing almost?
Not really even close. A 99% eclipse is still just a partial eclipse. So it might as well be 80% at that point, like we'll have here in Nebraska. So unless you actually get to see the sun completely block the photo, the sun is bright. So even a little bit of the sun is going to throw out so much light that you won't be able to see that corona and that chromosphere where you'll see it's. I mean, I showed you the image before. I can't explain the impact it can have on you to see it in person, and you know, your mileage may vary, I guess. Not everybody is invested as in this as myself and the people of the task force and us amateur astronomers all over the place. But I promise, even anyone who has just even a passing interest in space or science or just seeing cool stuff and life experiences, you will not regret traveling that extra hour to get as deep into the path of totality as you can.
Sometimes I explain to people when I talk about the eclipse, I says, tell me how you would describe a rainbow. I mean, if you've never seen one, I as much as I tell you what a rainbow looks like, you're not that impressed. But when you actually see one, it's pretty cool. Or what about the northern lights, right? Or even about when a storm comes, you feel that eerie feeling, right? Of how that is something you can't exactly explain, but it's very different, right? If from that point of view. So another question is, hey, look, we just had one in 2017. Here's one again. So what? I mean, isn't it like next year or so we're gonna have another one? So if I miss this one, can I just get to see the next one?
Yeah, and that's actually something I forgot to mention. This is our last chance to see one in North America for I think it's 23 years. Um, they happen all the time. So yeah, you can see one next year. I have a friend that's going to see one in 2027. She's just going to have to go to Egypt to do that.
Yeah, yeah, yeah,
Um, so if you're willing to travel, if an hour is too much, then
yeah.
uh, it's going to be difficult. But um, yeah, this is our last shot for a lot of people to see it here without having to make some major plans. And again, like I said, in 2017 we were in solar minimum. Now we're in solar maximum. So the amount um, of the corona is bigger now. There's more activity with prominences that you'll be able. I mean, you should be able to see some of the prominences that we have because some of them are really big right now, even sticking out off the edge of off the edge of the moon as it's going over. So
That's great. Well, we're going to wrap up here. I will say that I am part of I'm doing the Globe Observer. I will be looking at the clouds and the temperature
awesome.
drops. And I'm also doing a program called Soundscapes, where we're actually capturing the sound of nature during the eclipse, which compares to about 100 years ago, to see what they actually, it wasn't, of course, they did not have the audio devices, capturing devices, but they actually wrote down what they experienced. And so NASA will be comparing that, which is a very cool program. So there's a lot going on. It's like collapsing a couple-hour movie into a couple minutes. So much go by so fast that you'll probably miss most of it, because it's just too much. It's overwhelming at the end of the day, right? So it's
Yeah, I'd say one tip I would give to anybody who is going to go to totality. I know everybody loves to take pictures with their cell phones, and you can do that during the totality, but do one and then put it down and don't get so caught up with trying to get the Instagram moment with your phone or your camera. Don't get so caught up trying to capture that image. There's tons of people all over the country who do that for a living, who you can download their images later. Uh, Observe and experience the eclipse for yourself. Take that time. You only have, at the maximum 4 minutes and 20 some seconds. And if you're not right on the center line, maybe you only have 3 minutes or 2 minutes. Um, just be in the moment and take it in for what it is and really appreciate the fact that you're able to see that unique phenomenon, because there's a lot of moons and a lot of planets, but none of them really have the ability to block, like I said, that size relationship. Even in the entire galaxy, I guarantee you this is a very unique phenomenon, even with all the hundreds of millions of planets or hundreds of billions of planets that are out there. Um, we're very fortunate to have this, and at some point, thousands and thousands of years from now, a million years from now, you won't have this anymore because the orbits of the moon will have changed enough to where it no longer fully blocks the sun. So,
all right. Well, thank you for a great presentation, Mike. I'm looking forward to it, and I'm just crossing my fingers on the weather. We'll see what happens. This is the time of year when we really can't count on the weather necessarily, but hopefully nature will tease us to the end and give us a great show when it's all said and done, right? So,
Yeah, thank you, Don.
yeah, thank you guys. Thanks for everyone for joining as well. All right, task force members, I just stopped